Section 5.3, Multi-Step Inequalities. In today's lesson, students will calculate solutions to multi-step equations and apply this knowledge to word problems. To what? Very good. Today we're going to tackle two very difficult concepts. The first one is multi-step problems. Multiple step means more than one. Means what? More than one. And we're going to be focusing on inequalities. Inequalities. And if you look at the word inequality, in means not. So not equal. Not equal. And we have four symbols that we've learned. We have less than to the left, greater than to the right. We have less than or equal to, and we have greater than or equal to. And just to review, less than would be open circle to the left, greater than, open circle to the right. Less than or equal to, because it includes the value, it could be less than a closed circle to the left, and greater than is also a closed circle, goes to the right. Okay, so we're familiar with this, yes? Okay, so now we're going to do inequalities, but there's going to be more than one step. Now, these can be solved, okay, by doing the inverse operations, just like you solve an equation, okay? You go about solving it the same way as if there was an equal sign in the middle, but instead there is an inequality, which suggests that the two quantities may or may not be equal to one another. So let's take a look at this example, all right? 6x minus 10 is greater than or equal to 32, okay? So when you take a look at that inequality, you're going to notice two things. Number one, what is this called in front of the variable? This is called a what? It's called a coefficient. Right? There's a coefficient that's touching that variable, which means 6 is being multiplied by a number, and then when you subtract 10, that value that's going to be right here has to be greater than or equal to 32. Okay, so how do we figure out what is this number? We need to do the inverse operation. We need to do the what? Inverse operation. So how I like to do this is I circle the term that has the variable with the coefficient attached to it, okay? And I look at what is next to 6x. What is this? It's a negative 10, right? You're subtracting 10. Let's do the inverse or the opposite. So what's the opposite of negative 10? It's positive 10. Very good. Okay, so when you add 10 to both sides, okay, you want to bring down what you circled, which is 6x. You also want to bring down the inequality and add 32 plus 10. What is 32 plus 10? 32 plus 10 is? Good job, it's 42. Now, remember, 6 times x is 42. What number times x is 42? Right? You already know it's 7, right? But how did you get that? You have to do the opposite of multiplication, because remember, Mr. 6 and Miss X are married, right? If Miss X wants to be a single lady, she has to divorce Mr. 6. So she has to divide by Mr. 6. And then you end up getting that x has to be greater than or equal to 7. Now, how do you represent this? When you see inequality, how do you represent this as an answer? Because the answer is not 7, or is it? Could it be 7? Yeah, it could be equal to 7, or it could be more. So you have to represent, we call this a solution set graphically, and the critical value is 7. Would it be an open circle or a closed circle? Okay, if it has an equal sign, it does include 7. So we say it could be 7, or it could be more than 7. So we shade to the, what direction is this? To the right, okay? So you shade to the right, and what this is implying that any number that is 7, it could be 7 or greater, 8, 9, 10, 11, all the way to positive infinity, could be a solution to this inequality. Now, when you're solving these inequalities, you have to remember that when you multiply or divide by a negative, what happens to the inequality? Something happens to the sign. What happens? You have to flip the direction of the sign or flip the inequality, okay? Just to show you as an example one more time. If x was greater than 2, give me a value for x that is greater than 2. Give me any value, whatever it is. Why don't we say 5? Okay, let's say x is 5, all right? Is 5 greater than 2? Is it greater than 2? Absolutely, it is greater than 2. But what happens when we multiply both sides by -1? Okay, because if you multiply both sides, you're not changing the equation at all. What do you get? You get that -5 is greater than -2. Is this true? No, it is not. Okay, that is not true. That is why you have to flip the sign to make the inequality statement true. Now, this says -5 is less than -2. Is that true? Or is -2 greater than -5? Yes. So you have to flip. Why? Because we multiplied both sides by a negative. Now, it also works when you're dividing both sides by a negative. So let's go ahead and solve this inequality. Okay? Now, I want you to circle -3x. Why? Because we're trying to get x by itself, right? Just like in an equation. So we look at what is next to -3x. It's +7, correct? That's a 7, just so you know. This is a 7. All right. So what is the opposite of +7? It is -7. So we subtract 7 from both sides. Okay. I'm going to go ahead and bring down the inequality. +7 and -7 make 0. Bring down -3x. All right. So what is 43 minus 47? Okay. 43 minus 47. Okay, remember you have to borrow. It is 36. All right. So in this situation, we have that -3x is greater than 36. What do we have to do to get x by itself? Remember, -3 times x is greater than 36. So what do we have to do? We have to, yes, divide both sides by a -3. Now we're dividing both sides by a negative. So what will happen to that sign when we divide by a negative? Okay? What's going to happen to it? It's going to flip. So it was greater than. We're going to flip it to less than. Okay? And what is 36 divided by -3? Okay? 36 divided by -3 is -12. Very good. So the solution set is all values that are less than -12. What does that look like on a graph? Okay? So you have -12 as the critical value. Will it be an open circle or a closed circle? What do you think? It will be? It will be open because it does not include 12. It has to be less than -12. And that means you're going to shade to the left. Less than left. Remember that, okay? All right. My hotline's blinking. This is Miss Cotran. You don't understand your homework. Why are you calling me? On my cell phone? All right, I'll explain it to you. You want to solve an inequality. There's a few steps that you need to take. It's just like an equation. Without an equal sign, don't make that mistake. When I see an equality, well, that could only mean one thing. The answer's in a solution set. Well, you can show them graphically.
less than open circle to the left, greater than open circle to the right. And if the sign is also equal to, close circle cause the value it includes, less than open circle to the left, 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 greater than open circle to the right. And if the sign is also equal to, close circle cause the value it includes. Please don't call me on my cell phone late night when you need help on your homework. Don't call me on my cell phone. Ask questions in class, then do your work. So now let's do your favorite, which is an example with a dun 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 fraction. Yeah, there's a fraction in it. But don't be afraid of fractions. I don't understand why students are afraid of fractions. I mean, they're less than a number. They're less than a whole number, and you're so deathly afraid of them. All right, never mind. Okay, so let's go ahead and do this. Now, how did I know there's a fraction? Because you know what? I'm going to go ahead and circle the coefficient with the variable. I'm trying to get x by itself, just like in an equation. Okay, so we look at what is next to 2/3 x. Okay, now this is, -3 is less than or equal to 2/3 x plus 9. So what is next to 2/3 x? It is a positive 9. So what is the opposite of positive 9? It is -9. Okay, so we're going to subtract 9 from both sides. If it helps you to separate both sides of the equation, okay, you can go ahead and make a T like I normally do. Separate both sides. Okay, so positive 9 and -9 make 0. You could bring down 2/3 x. And now 2/3 x is greater than -3 and -9. Okay, remember how to add -3 and -9? Same signs, add and keep. Add them together. The answer is -12. Okay, so if -12 is less than or equal to 2/3 x, how do we get x by itself? How do we do it? How do we do it? Okay, so I've showed you 2 ways to do it. I think the simplest way is when you see a fraction and you want to get rid of it, okay? Because what's happening here is it's x is being multiplied by 2 and then divided by 3. Well, in order to undo this, we would multiply both sides by 3 and at the end divide both sides by 2. But the shortcut to that is multiplying both sides by the reciprocal. Exactly. So multiply by the reciprocal, which is 3/2 or 3/2. Okay. I'm going to go ahead and put this in parentheses. Okay. All right. So these are being multiplied. So we have -12. Let's do this side first, the left side. -12 times 3 divided by 2. A lot of different ways you could do that. That could be -12 times 3 is -36. Divide that by 2. That would be -18, correct? We could also do this. We could because this is really over 1, so when you're multiplying these fractions together, you can cross cancel or cross divide, right? We could go this way. We could divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And we again see that 3 times -6 is still -18, which is the same as -36 divided by 2. Is less than or equal to, very simply, when you're multiplying reciprocals like this, okay, when you multiply reciprocals together, by definition, they make 1. Watch. 2 times 3 is 6. Over 3 times 2 is 6. That's 1. So it really just gets rid of the numerators and the denominator, and you're left with x. X is greater than or equal to -18. Okay, so can you draw a graph to represent the solution set? Can you do that? When the answer is on the left and the variable's on the right, can you do that? What do you have to do? You have to switch. Now, when you switch the places, you also have to flip the sign, okay? Because this is saying, if you read it like the way you read a book, it says -18 is less than or equal to x. If you read it right to left, it's saying that x is greater than or equal to -18. So if I switch the places of x and -18, I also must flip that sign. It was less than, I need to make it greater than. And when it is set up like this, then I can graph the solution. Okay? I'm going to graph the solution. The critical value is negative 18. Okay, is it an open circle or is it a closed circle? What do you think? It is closed because it includes 18. That's correct. And in what direction do I shade? To the left or to the right? To the right. Because it's all values that are greater than negative 18, like negative 17, negative 16, and so on, all the way to positive infinity. Okay? Go ahead and get that down. So just so we don't forget, I wanted to include a problem that had parentheses, because when you see parentheses, you have to do what? Distribute, multiply, okay? So I know that we've been teaching you to distribute that negative 3, right? Negative 3 times x and negative 3 times negative 4. So we're going to go ahead and do that. Negative 3 times x and negative 3 times negative 4. So negative 3 times x is negative 3x. And what's negative 3 times negative 4? It is, what is it? Positive 12, that's right. Is greater than negative 9. All right. So, again, what are you going to do? I would circle negative 3x, and what should you do to both sides to get 12 over there? You're going to subtract 12 from both sides. Very good. All right. So if you bring down negative 3x, you're going to get that negative 3x is greater than, 12 and 9. Same signs, add and keep. You get negative 21. How do you get x by itself? What do? You have to divide both sides by negative 3. When you divide by negative 3, what happens to the inequality? It has to do what? It has to flip because you're dividing both sides. So you get that x is actually less than, what's negative 21 divided by negative 3? It is positive 7. Okay? So if you graph this, seven is the critical value. Is it going to be open or closed? It will be open, and you're going to shade to the left because it's all values that are less than 7. Okay? Go ahead and get that down. So let's take a look at a real-life example of a multi-step inequality. Okay? It says Haley is saving $500 for an iPhone. Okay? She currently has $125. She saves $15 per week. How many weeks will it take for her to afford the phone, including taxes and accessories, like maybe a cover for her iPhone, right? Okay? So, she needs to afford the iPhone and more. Yeah? Because you just don't buy a phone by itself, right? You have to buy all the stuff that goes with it. So that is why we have an inequality, don't we? Let's take a look at the numbers. Let's box the numbers. She has $500. Oh, wait, she needs to save $500. She is saving currently. But right now, she only has, unfortunately, $125. Okay. So she needs to save $500. And we've talked about the fact that will it cost her actually more than $500 if the phone itself maybe is $500? Because she wants to be able to afford the taxes and the accessories, so it's going to be at least $500. If it's going to be at least $500, then she needs to save at least, which means she needs to save $500 or more, which means greater than or equal to $500, right? It'd be great if she could save more, then she could buy more stuff for her phone. Anyway, so right now, she has $125. So I'm going to go ahead and write this here. That's what we call the constant. That's what she has now. She wants to save, or she is saving, $15 per week. Per week. So if it's $15 per week, okay, in 2 weeks, she'll save how much? 30. And in 3 weeks, she'll save 45. So we are multiplying. The per really tells you to multiply. And so we have 15. We're going to go ahead and put x. And what does x stand for? It's going to stand for the number of what? The number of weeks, right? And of course, the question at the end asks us, how many weeks will it take for her to afford her phone? How many weeks will it take for her to afford her phone? Not just her phone, but accessories. So we have this inequality set up, right? And all we do is solve for x. So we could subtract what from both sides? Subtract 125. Bring down 15x. 15x is greater than or equal to 500 minus 125, right? Which is $375. Okay, so 15x is greater than $375. Divide both sides by 15. 375 divided by 15. All right, so that's 25. So she has to save for 25 weeks, well, either 25 weeks or more to make at least $500 in her savings, okay? That's really a long time, 25 weeks, because that is about almost 6 months that she'd have to save. If she saves for exactly 25 weeks, then she will have $500. But if she saves for more than 25 weeks, she can afford her accessories and her taxes on the phone. Okay? So go ahead and get that down.